Hello, everybody, and thanks for stopping by. I want to take just a couple of quick seconds out of the gate to thank everybody that has recently subscribed, commented, or viewed a video that I have produced and uploaded. A lot of time and effort goes into the videos to make sure that the content is qualifiable and reliable. So that being said, again, thanks to everybody that has subscribed. For those that have been following for a while, I know I've been very, how can I put it, very not around, just plain old fashioned not around. And I do have a very, very good reason for that. I'm actually in the process of just a very short period of time away from taking my CCA lab exam. And so that's where the majority of my time has been spent. So basically, that's why I haven't been around. So if you haven't seen any videos uploaded lately, that's why. So to get down to the nuts and bolts of this particular hangout, I wanted to give everybody an update that I will be going through and completely redoing the CCNP routing switching certification exam. So the courses that you have previously seen from the route and switch series that I put out some time ago, those are going to be completely redone and completely gone through and revamped. Now, a lot of the same technologies still apply, and I will be going through and redoing all the content. So if you have watched the videos in the past, it's going to be a lot of repeat information. I was actually going back and forth with tossing the idea around whether or not I wanted to just add content to the existing videos or if I wanted to completely redo it. And so I decided that if I did a video or two a night for a period of, however long that might take, 2 or 3 months maybe, that I would be able to successfully update and put out the quality content that is necessary to help you guys that are pursuing the CCNP routing and switching exam or I should say exams, to get the knowledge you need to pass the test. And so as you can see in front of you, I have the lab exam blueprint for the 300-101 exam, which is the updated exam. So the 642-902 for route, 813 for switch, and 832 for T-shoot, which I never actually did. I had planned on doing it, but I never actually got around to producing it. I will have a update for that, and where I'm going to be starting off with that is with route. Then we will move into switch and then finish up with T-shoot, because it makes sense, assuming that you're coming from a perspective where you don't do any troubleshooting. You're just an implementation type person. You've been given information from a senior individual that tells you you need to do XYZ on this particular device, and this is how this is what you need to do, and then you just go in and do it. So maybe more or less you're just following orders. You're not a design engineer or anything like that, but you want to become that senior person. So this is going to help you get there. I can tell you from my professional experience. So this is my own personal experience working in the IT industry in the networking space, that once I went from CCNA to CCNP, I saw a dramatic shift change in the roles that I now I fill from a consulting and from a contract perspective. I no longer do the low-level minor detail of making sure that circuits are staying up and things like that. I'm more high-level architecture, engineering, design, all that type of stuff. And you'll find very quickly through your understanding of the technologies where design and implementation, where the boundaries are, and how you can't go too far this way because there's a design issue. You can't go too far to the left because there's a implementation restriction or incompatibility or something like that. It could be a technology related issue. It could be an iOS issue. It could be a platform limitation. So you'll find that as you go through. So what I'm going to basically do really quickly here is I'm going to go through the exam overview just real quick with you guys. And I wanted to do something live because the fact that in case anybody was trolling through and they wanted to, see hear me for a couple of minutes, that would give you the ability to do that. But what I'm going to do basically is kind of give you a 5-minute overview of the exam blueprint and kind of let you know where I'm going to be putting all these pieces in. Because from my experience of studying for the CCIE, which I don't have yet, but I'm hoping that by the time I start releasing videos, I will. So probably in the next month or so, maybe a little bit longer. I don't want to give you an exact time frame because the fact that if I don't pass, I don't want you guys to ridicule me. But because the CCIE is a very difficult exam to pass. So, but anyway, so the high-level overview of this exam is pretty straightforward. So if you were to download the CCIE route switch blueprint, maybe because you have nothing else better to do at your time, I doubt that would be the case, but maybe you're interested in going that route. This is basically a stripped down, watered down version of the same thing. So the network principles, you're going to have a lot of the same things you're going to see in the route switch for the written exam and for the lab exam. So in the written exam, you'll see network principles. You won't see that in the lab exam because network principles are going to be more of a theory-based perspective they're going to test you on. So I'm going to be doing this probably towards the beginning, just so you guys have an idea of what's going on. And there is an assumption that you're coming to this, to these exams and to these videos with at least a CCNA level understanding. So I'm not going to deep dive into what is an IP address, what is a MAC address, and how do they work together. I'm not going to go into that. I'll explain why ARP works the way it does with an IP address and a MAC address, and then I'll go into more detail like what's an ICMP unreachable, what's that type code, how does this work, why is V4 and V6 fragmentation, why does that happen? Things like that. So you guys will have an idea of what's going on, and I will talk about things like global synchronization and the bandwidth delay product and stuff like that that'll come into play inside of your operations. And for the most part, I'm going to keep it relatively straightforward. I'm not going to go into a ton of detail, but it's important to understand that these things do exist. So as I scroll down here and come down into the layer 2 technologies, as you can see, there's a very, very small section that is actually in layer 2. And where they're focusing is explain frame relay. Now, I'm taking that as when I took the CCNP exam, the route exam, there was frame relay on there. Now, you didn't actually have to do anything with it. As far as I can remember, it's been like a year and a half since I've taken the exam, so I don't honestly remember what was on the test. So, but the authentication, we're talking about the password authentication protocol, PAP, and the challenge handshake authentication protocol, or an MD5 hash, essentially. And we're going to talk about how these pieces come together. We're going to work with frame relay and show you guys how that works and go from there. And then we're going to spend the majority of our time on the big 40% block of layer 3 technologies. Now, coming back up here to layer 2 technologies just for a touch, there might be a situation where you might have to run PPP between two interfaces or two routers, and then you're going to run OSPF over that. That would totally work. So we're going to come down back into our layer 3 side, and we're going to cover, I'm going to break it up to where we'll talk about address types in ARP, and we're going to move DHCP both for IPv6 to those respective areas of the exam. So the services. So a DHCP relay and server technically should be in your services because the fact that those aren't things that you would do for addressing. And you're like, wait a minute, DHCP is for addressing. You're absolutely 100% right, but I don't feel like it belongs into addressing and subnetting. That is a situation, that's something completely different. It's how you get an address. So we'll talk about that in a different situation. We'll talk about address types, how these would work, and then ARP and so on and so forth. And then we'll do the same thing for IPv6. Unicast, EUI64, neighbor discovery, router solicitation, router advertisement. Those things will be covered out of the gate. Then we'll talk about auto configuration, where we don't put an IP address on an interface and we type in IPv6 address is autoconfig, or what have you. And then you learn the address from there. And then we'll talk about static and default routing, which are probably going to be just one video where I wrap the two together. And then we'll talk about the protocol types. What's the difference between EIGRP and RIP and how they alike? What's link state look like for OSPF? And I will touch on ISIS. And then we'll get into path vector with BGP. So I just kind of gave you an insight as to what each one of those are. We'll talk about admin distances and all this area that you see between 3.6 and 3.15. Those things will be done after, parts of it. I will filter in different areas, like describe administrative distance. If you don't know what administrative distance is, I will cover that. But It's how you can determine which protocol is going to win. So administrative distance basically means believability. How believable is that protocol? Where EIGRP has an AD of 90, OSPF was 110. So EIGRP will be preferred over OSPF. I'm an OSPF implementation type person myself. I don't really care for EIGRP, but you need to know it. Then we'll talk about VRF Lite and how that works. And then we'll start getting into the implementation piece. We'll talk about RIP version 2 and RIP NG, which is IPv6 for RIP. So we're going to talk about IPv4 and IPv6 for both RIP, EIGRP, OSPF, and BGP. We're going to cover all 4 of those topic areas. And by the time we're done with that, you should be in pretty good shape for everything that you see on the blueprint. And by that time, we should be in good shape. And then we'll talk about our VPN technologies. And the VPN technologies, they have configure and verify GRE, which is literally, no kidding, is 3 commands on 2 different routers. You have a tunnel source, tunnel destination, and a tunnel IP address. Once you have those 3 pieces in there, as long as your tunnel source and tunnel destination are reachable through IGP or through BGP or however you have it set up, as long as the addressing you typed in there is reachable and you can ping it, then your GRE tunnel will come up. So we'll talk about how that comes in. We will actually go through and deploy 2 different DMVPN clouds with a single hub, because DMVPN is a pretty heavy, it's pretty heavy in the CCIE. So I've spent a significant amount of time working on DMVPN, and we'll also talk about cryptography. Even though it's not in the exam scope, most people I know that deploy DMVPN run IPsec over it. So where DMVPN itself is a routing technique to allow you to spin up on-demand GRE tunnels between sites and then encrypt the data with IPsec profiles. We'll talk about that as we go along. And then we'll get into infrastructure security. And infrastructure security is going to start off with understanding what AAA is, which is not the Automobile Association of America. We're talking about authentication, authorization, and accounting. We'll talk about how that gets implemented and go from there. Not a ton of security, as you can tell. They've actually moved heavily away from the security and put that into more of the security track. That Cisco did it this way because in the greater scheme of things, I felt like I was spending too much time in security in route switch. Just the route switch exam, the routing exam, I should say, that I took a year and a half ago. When I took that exam, there was a heavy dose of IPsec on there. And I really didn't know anything about IPsec, so I had to do a lot of guesswork. I don't think I did very well on the IPsec section, so I've turned that around. I know it quite well now. Definitely not an expert, but I'm more knowledgeable than I was. So we'll talk about Radius and TACAX and how you can have call out to a TACAX or Radius server, where TACAX is Cisco proprietary and Radius is open source. So you can run a Radius box or a Radius service, or as a Radius role, one of the two, in a Server 2008 or 2012 deployment, and then you can have your routers check the Radius server to see who's allowed to do what in the network, the NPS, I think it is. I'm not a server engineer. I do a lot of VMware, but I'm not a server guy, which some people might think that doesn't make sense, but that's okay. Privilege authorization fallback, which basically means you're going to tack on local database at the end of your AAA TACAX command, simply is all you're going to be doing. And then we'll talk about verification and configuring of device access control. So we'll talk about securing the data plane with control plane policing. We'll also talk about securing the console lines. So any of your remote, your VTY lines, console, and aux ports, which VTY simply means Telnet and SSH. Aux means a modem, and console means you're going to plug that little blue funny-looking cable into the router's console port, and you're going to manage it from that way. Then we'll talk about the different security features. So we'll talk about access lists, IPv6 traffic filters, and URPF, or unicast reverse path forwarding, and how that would work. And we'll get into, actually, I want to talk about URPF, but I'm going to leave that for the actual the videos. So we're going to talk about more infrastructure services like console and VTY. What's the differences? Why would you use one over the other? We'll talk about Telnet, the web, secure web, SSH, and the secure copy capability, and then TFTP and FTP. So I will actually demonstrate on my home router that I have. It's a 3725. It's the router that I currently routes my home network, and I will show you guys how to manipulate the web services and the stuff like that, and do an FTP downloads, all like TFTP, the operating system, down from the router, and show you guys how to do that. There is ways to do this in GNS3, but I think there's more. It's more applicable if I was to show you on a physical production device and just run it through my home computer and just show you guys how that would work. And then we'll talk about SNMP version 2 and version 3, which actually is V2C and version 3. We'll talk about that. We'll get into logging, and we'll talk about how the logging piece works with local logging, syslog debug, conditional debugs, where you call out a particular debug feature. So like you want to debug IP packet, but not IP packet detail. And then we'll talk about timestamping, and we'll talk about some of the other things like sequence numbers and how you can see if someone's been trying to delete syslog messages. And then we'll talk about NTP, the master, the client, version 3, version 4, and NTP authentication. Relatively straightforward for the most part, but it's important to understand how those pieces will come together. We'll turn one of the routers into a NTP master, and then we'll authenticate. And then we'll talk about DHCP. We'll talk about the client, the server. I'm actually going to take a little bit, this entire section, I'm going to probably take you to the CCIE level with, because realistically speaking, if I stop at the CCNP level, there might be just a couple of extra commands and maybe a feature or two more that would take you to the expert level on it, which in the CCIE exam, they don't take you to that depth. They're going to talk to you about how the DHCP pool, the client ID, how you would associate those things. I'll show you guys how that works. It's really, really simple. And you can do all this in GNS3. It's very, 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 very easy to do. And then we'll talk about, I lost my mouse. We'll talk about NAT, PAT, and dynamic NAT. Really, really easy to work with as long as you understand the concepts behind it. And I'll explain how they'll break those down. And then we'll get into IPv6 NAT, which if you've never heard of NAT, NAT 624 or NAT or NPTv6, which is NAT Protocol Translation v6, which is how you bring the v6 internet into a v4 environment. I'll talk about how that comes into play, which is actually how, if you have a v6 native IP address from your service provider, some are doing this. Basically, what you would be doing is you'd be taking that v6 address, translating it to a v4 address, and that's how you'd be able to reach things like google.com with the quad 8 address and things like that. But we'll go into more detail on how that would actually work in more detail later. We'll talk about service level agreement architecture and why you would want to use that. And then we'll talk about verifying that with ICMP. We'll talk about tracking objects. So this is basically how, for instance, you're doing some sort of policy-based routing, and you want to make sure that you're preferring one route over the other via PBR, and you want to make sure that the next hop is reachable all the time. If it's not, you want to bounce over to the other link you might have. We'll talk about how PBR comes into play. Really simple to use, and you would be surprised at how widely used PBR is in the real world. It's actually a very easy thing to use. I think it's a little too widely used. It's an easy fix for some problems that are in environments that I've been in, where you could just manipulate a routing protocol a little bit, and that would do the same thing. But it goes to show you the people that are truly understand the technologies versus that know a quick way to fix it. PBR is typically the way they go, because it's relatively non-intrusive. And it goes based off the source of the traffic, where a routing protocol basically goes off of the destination. So we'll talk about that more in detail. And then we'll talk about NetFlow and how that works. And NetFlow is going to be a big piece, especially if you work for a service provider, or say, for instance, you work for a service provider. There's a service and a services, where, for instance, you might be working for Time Warner Cable, or you might work for Yahoo. And Yahoo is a services provider where they do the web-based email, things like that. Or you might have some sort of thing like with Gmail or some other type of feature where you're trying to charge the customer based on how much data they threw. So like, for instance, AWS, they do something similar. I don't remember exactly what their technology is called, but they charge you based on how long your service servers have been running in their environment, and how much compute time you've been using, and then how much data you've been forwarding back and forth. Usually it's free to upload, but the storage piece is where they get you. So, but then again, I'm not an expert on AWS, but that's pretty much the topics that I wanted to cover for that. And then I wanted to give you a quick rundown on the topology. Topology is relatively straightforward. It's not anything super huge. I played with it for probably about an hour the other night to make sure I would actually get everything dialed in. And if you have any questions for me, I will be moving this entire topology. This is GNS3 right now. I'll be moving over to Paint, and I'll be blowing up the loopback addresses and my email address, so you guys can reach out to me whenever you'd like. But basically, the way you could look at this is we have our OSPF environment over here, where I haven't labeled this all out yet, but once we actually get to the particular protocol we'll be working with, then we'll actually get into the details of which interfaces are going to be running in which areas. I will have to cover single area, multi-area with virtual links and things like that. So we'll talk about that and the different pieces to it. So if you're coming from the CCNA and you know how to turn router OSPF1 on, you know how to advertise a route, or I shouldn't say that, you know how to go into and type in a network statement that matches a configured IP address, then you know how to turn the OSPF process on an interface. And then if two interfaces on two different routers match, they form an adjacency. So you go from there. So we'll take that piece and we'll build upon it. So we're going to take what you know in CCNA, and we're gonna start adding to that. So by the time you are done going through the OSPF section, you'll be good to go with OSPF. You should be almost to the point where you can start looking at it as at an expert level. Not saying we're taking you to the expert level, but you'll be able to understand workbook topics and stuff like that, depending on if you use, like, for instance, I use INE or Internet Network Expert for my all my Cisco stuff. You might choose to go IP Expert. So whichever way you choose to go is up to you. But by the time that I get you through this entire CCNP route section, you should be good to go. Same thing with EIGRP, relatively straightforward topology, but at the end of the day, it's what you can do with the protocol, not how big the protocol is. So, or how big the topology or your design or implementation is. And then, I don't know if you guys noticed this right here, but 6 and 13 are going to be BGP routers. So we're going to have two different ISPs. And what I'm going to do for the redistribution piece, so once you got EIGRP configured, frame relay, and then you have OSPF over here and frame relay, and then OSPF running over frame relay, then what we'll do is we'll get into the redistribution piece. So I will actually extend EIGRP to 6 and 13. The same thing with OSPF. I'll extend that to R6 and R13. So R6 and R13 will be running both protocols, and we'll talk about redistribution, route feedback, manipulation with tags, and how you can go and just configure a distribute list to call a prefix list to prevent a particular route from coming through. So all those good features we'll talk about in more detail later. And then once we get a little farther along, once we're done with all of that, and we have BGP done, and we have all of the what I'm planning on doing for each protocol is doing V4 and then following it up with V6. Because in all honesty, when you're turning the IPv6 piece of it on, there's just a few commands different, and then you're good to go. And for those of you that are interested in learning RIP, which is still an applicable protocol in very small companies that don't have the ability to run a bigger operation like Cisco or Juniper, we're going to run RIP in between 8 and 9 on this link right here, and we'll do that for V4 and for V6. So you'll see how that all comes into play, and I'll walk you through the commands and how that would work. And then we'll rip that out and we'll replace it with EIGRP. And then once we have that done, that'll bring us to the VPN piece. The VPN piece, we're going to run, I'll show you guys how to configure a GRE tunnel. It's really simple. 3 commands on 2 different routers, your tunnel is up. But I'll talk to you about how that could break your network depending on how you have it set up. And then what we're going to do then is we're going to run DMVPN. So I'm going to run DMVPN with OSPF here, and then I'm going to run it with DMVPN with EIGRP over here, and then we're going to run IPsec on top of that. So IPsec is not in the, like I mentioned earlier, it's not in the topic domain for route, but it is for route switch for CCIE. So, and in all honesty, and in real world deployments, you don't run DMVPN and not have IPsec on top of it, because DMVPN itself is a routing technique. IPsec is used to encrypt it. So you can run DMVPN all day long and never touch IPsec. That's actually how you are able to understand the protocol in more detail with a protocol called NHRP or NHRP. You're able to use like Wireshark to dig into the details and run debugs and see how things are working. If you're running IPsec, you won't be able to see anything in the Wireshark because everything's going to be ESP packets. So we'll talk about that more in detail when we get to that section. And then that will pretty much bridge us towards the end of the videos. So the end of, I'm sorry, the end of the protocols. So then we'll get into things like our security and our services running, say, for instance, that R1 is a DHCP server and 16 and 17 need addressing. So we'll pull DHCP through that. We'll also do some DNS, and then we'll get into things like NetFlow and how you can calculate that, who the top talkers are, and go from there. So that pretty much sums up how the routes section of the CCNP is going to be put together, and from there we'll be I think we'll be in good shape. So I will make sure to have the interfaces applied where they need to go, and then we'll go into the more of the details when we get there. So I hope everybody is going to enjoy it. If, like I said, if you have any questions or concerns or comments, there's one question. Am I going to be releasing the .NET file? I will be. I will be releasing the .NET file previous to my actual deployment of videos. So you guys will be able to spin this up. I am using, I will have to figure something out with that, because I'm using a experimental version of code for the 7200s. So most people don't have access to that. So if you have 7200s running in your environment, you might have to reassociate or just build it out. I mean, this isn't super big, so it should be pretty straightforward for you to build. I will also put up the initial configs, so just the IP addressing and things like that. We will be walking from start to finish on all the routing protocols and all the other good stuff that goes along with it. There is another question. For the switch and T-shoot exams, how are you going to be deploying those, or how are you going to be deploying? I'm not sure if you're deploying or whatever that word is. Basically, what I'm going to do is once I'm done with route and that's completely done and uploaded, I'll start on switch. And then I'll go through switch and I will walk through all the technologies for switch that are applicable. And then from there, I will walk into T-shoot, which I don't know what Cisco has released for T-shoot yet. I haven't seen that updated topology. I know what I saw for T-shoot when I took the CCNP, but at this point in time, I don't know what's going to be what's there. I will have to look when I get there, but I'm going to definitely make up a lot of trouble tickets. I will break the heck out of a network, or maybe only partially configure things and you'll have to finish it, or tweak things, and we'll go from there. So hopefully that answers your question. But that's pretty much what I wanted to cover in this video. So you guys would have an idea of what's going on, why I haven't been around, and why I've been so quiet. So, but beyond that, feel free to continue watching. I hope this has been informative for you, and I would like to thank you for viewing.